Welcome to APEC. It's May 28th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Dr. Julia Mossbridge will discuss reverse causality in photons. David Alzofon will present on NMR gravity modification, and Ted Pittman will demonstrate his patented impulse driver. Mark Sokol will be joining us live from the ISDC Conference, and we're going to be finishing off this event with open discussion and ad hoc presentations by conference attendees. So the usual quick reminders: you can view conference replays, details, and speaker info on our website at www.altpropulsion.com. Please save your questions for the Q&A session after each presentation. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows, and I'll read that again to remind you guys in a bit. You can also type those questions in the chat, and we will go through them after each presenter finishes. So now I am honored and pleased to introduce you to our first guest. The idea that events in what we call the future could influence events in what we call the present or past has been called retrocausation, retrocausality, time symmetry, or atemporality. Dr. Julia Mossbridge will discuss experiments on a duration sorting effect where different experimental run durations appear to regularly produce different photomultiplier output that depends on future durations. So let's welcome Julia to today's event, and I will hand things over to her to get started.
Hey, thank you, Tim. Thanks for having me.
Julia.
Thanks. This is my first time at APEC at all, so I'm sort of shooting in the dark. And my background is in cognitive neuroscience, experimental psychology, and most recently, I've been doing some experiments in optical physics. With consultation with some physicists. So it's a wide background in the world of science. It's very much sciencey, but I haven't been spending a lot of time in this community of the folks who are interested in alternative propulsion, in UAPs and UFOs. And so for the last maybe 2 years, I started reading up and getting to know the community a little bit better, but I'm still basically a newbie. So I may say some things that just sound naive or not right or whatever it is, and because I don't have the jargon or I don't have the same sources that you all have. But I'm hoping that what I'm going to say today can actually spark some new ideas for you all and in the field, despite the sort of newness of my presence here. So I'm going to go ahead and see how my slides do. So I have it's going to take about 40 to 45 minutes to talk about what I'd like to talk about. And before I begin, I just want to say thanks to University of San Diego, Department of Physics and Biophysics. They're hosting me as an affiliate professor there. Institute of Noetic Sciences, where I'm a fellow there. And I created this nonprofit in 2019 called the Institute for Love and Time. And I'm the executive director there. That's where my paycheck comes from. So those are some affiliations that I just want to thank before I begin. And I just want to point out cool graphics. Thank you, Tim, on this beautiful APEC slide. So let's start with this. This is recently Kevin Knuth. Do you pronounce the K? I think so. Kevin Knuth, whom I very much appreciate in terms of his writing and his way of thinking about this stuff, recently wrote an article in Medium called Mitigating Biases and Naivete in UAP Studies. One of the lines that I really loved was, mainstream science has been stuck in a tautological loop where scientists do not study UFOs because there's no scientific evidence of UFOs. There's no scientific evidence of UFOs because scientists do not study them. In other words, there can't be any scientific evidence of UFOs because studying UFOs is not a thing that a scientist would do. So this is a tautological loop of which I'm very familiar with this loop, because it applies exactly to what I've been doing for the last 15 years or so, which is trying to understand the kind of thing that that we would call retrocausality in humans, or some people call precognition. So let me tell you what that is, because I've been in the same boat for a while here. So these are the kind of data we get with precognition experiments in biology and psychology. The first thing we do is we record some data. It doesn't matter if it's digital or analog, you get some data. Usually it's on the person's behavior. In physiology experiments, it's about the person's physiology. There's some kind of a branch choice. It's usually a binary choice, but it could be a trinary choice or quaternary choice. But there's a choice that needs to be made by the person. And then you look at what happened in the area before the data and how it corresponds with the choice. Now, the tricky thing here is that the choice itself is related to an external variable that is randomly selected. So the choice itself cannot be predicted according to usual means. This is not usually a pseudo random number generator. This is a true random number generator that selects the stimulus that prompts the choice. And sometimes the choice isn't even so obvious. Sometimes the choice is to sit there and watch a screen where you see images of plane crashes versus images of little flowers. And the retrocausal piece is when we find out that what happened in one before we were recording the data actually relates to which choice was made. So in other words, this randomly selected event that is dictating this choice at time 2 seems to be influencing, we're going to call it influencing, even though causation is a question mark in my mind, but in any case, seems to be influencing what is recorded here. So this goes on and on and on. This has been documented for more than 50 years. The effect sizes continue to go up for this kind of experiment, the more methodologically sound it is. And I got into the field about 15 years ago after reading the literature and seeing that these kind of effects seemed to be happening. And I kind of started believing that they weren't lying, but I wanted to see them in my own hands. And so I did these experiments to see if I could see them in my own hands. And indeed I did, and I'll show you an example in a second. There's an example. So this is an example that's not going to convince anyone, and I don't really care if you're convinced about these kind of things. That's not really the point of this talk. But just so you understand what I'm talking about in a way that matches the paradigm with the result. Here we have linear time in seconds from -10 to 10 seconds. And here we have change in skin conductance in microsiemens, which is just a measure of arousal. It's like basically related to how much you're sweating. The future, the trials on which in this task, people were asked, is a gambling task, randomly select something that you think is going to be the target. On the trials where the folks are about to be correct, within 10 seconds before they learn that they're correct, which is this vertical bar here, they have an arousal response that matches the post feedback arousal response. When they're about to be incorrect, they have this lower arousal response or none. And this is statistically significant. This is a group of 30 men at Northwestern University. This is a one trial task. So they do this one time, and this is what it's like. Now they did do it 39 more times after this. I just looked at the first trial because I was concerned about effects from preceding trials. This is just an example. If you want to read more about this kind of work, you could go to this URL and you can read more about this kind of work. It's not what I'm here to talk to you about today, but I'm here to explain that the reason why I started getting interested in this kind of retrocausal effect is at the seconds time frame, is because it seems to me there has to be a physical explanation, like as in physics. And so that's why I started to do physics experiments to try to understand that better. So in usual sort of what are called retrocausal experiments in physics, this is below the line, we have things like delayed choice, quantum eraser, experiments in physics. And the way they work is very similar, except for a key difference. You don't record the data before this choice is made. And then afterwards, instead of looking at what happened because you didn't record any data, you infer what happened. So this is an example of, did we get which path information? If we got which path information, then we have a different result than if we didn't get which path information, let's say in a double slit experiment. So we're going to assume that the photons somehow knew that we were going to make this choice in the past. That's the inference. But another way, of course, to solve the problem is to say, well, there's this, it's got some kind of multiple growing block universe. And so you could go into different future paths. The difference here is, the key here is recording data before this random choice versus not recording the data. That's really the key. So it's like this. In those kind of delayed choice experiments, it's like with Schrodinger's cat, all you're allowed to look at is afterwards. The cat's keeling over and the cat's dead. All right, we're going to assume back here that the radioactive poison thing went off, right? Or if we see this path, that the cat's alive, we're going to assume that it didn't, but we don't get to look here. So it's all assumptive. So that's the key difference, is that now I wanted to look here because that's what we're doing in the precognition experiments. We're looking here before that branching point, and we're looking and recording before that choice is made. So these are experiments I called ambiguous causality experiments because I'm not sure about the causality. I'm not even sure causality exists. So I'm just going to call them ambiguous causality experiments. And they're basically exactly the same as precognition experiments, except with physical measures. So what do I mean by physical measures? In my case, I'm looking at photons. I think they're a great choice for very many reasons, but I won't go into. But I will say that I'm going to go through the double slit experiment really quickly so that you can understand my motivation for doing the experiment I'm about to show you. And later, I'm going to talk about what I think this has to do potentially with UAPs or some questions that we ought to be asking ourselves. So ride with me on this, and there'll be time for about 15 minutes of questions later if something gets caught up in your mind. So imagine a low-level light source that's pumping out one photon at a time. And imagine a piece of metal with two vertical holes in it called the double slit. And then you get this, what you get after some time is an interference pattern on a screen, on a detector screen, okay? So this is the simple experiment. And so what is the explanation for this? What we assume is that the single photon goes through both slits at once and interferes with itself and causes the interference pattern. So that's what we assume. But I'm really interested in looking at the difference between what we assume and what we actually know. What do we actually observe? The lamp is on for a given duration. Okay, yes. And that there's an interference pattern over time. That's exactly what we observe. So actually our inference about how we got there, this is just one example. It's basically non-locality in space. This photon is in two places at once. It interferes with itself. It causes the interference pattern. What about non-locality in time? It's just as weird. We just don't talk about it. So what if this is happening? You have this just emitted photon, and then you have a photon that's going to be emitted in the future. So this interferes with a future compatriot that goes with through the other slit, and you cause an interference pattern. Super weird, but not at all. Not at all weird compared to non-local in space. In fact, just exactly as weird. It's non-local in time. So how could you actually test? I mean, this is an interesting idea, but who cares? How can you, I'm an empiricist, how can you actually test whether this might be going on? So one of the implications of this model is this. Oh, sorry, this is just pointing out that Feynman in quantum electrodynamics basically said that a time-traveling photon could be absorbed before it's emitted. So this is just a little light cone observation of that. And you can imagine here's a photon here and a photon here, and that it's really irrelevant whether it's emitted or absorbed first. Okay, it's just giving Feynman his due. But now back here. Okay, so let's imagine we have this scenario. Let's assume that all photons in a particular experiment are available to be absorbed, including those that are not yet emitted at a particular present moment, and those that are not yet stimulated in their emission within the photomultiplier, because let's assume we have a photomultiplier where you can have photons stimulated from these electrons. Okay, so what do you have? These are like little camps. You have the camp of photons that consists of a short duration experiment. That's this many photons. You have a camp of photons that exists for a medium duration experiment, that's this many, and a camp that exists for a long duration experiment, so that's this many. So what, right? Let's look at the first period of time for each of these. The first period of time is going to take sort of the same percentage of photons at each of these, but that percentage is actually going to turn out to be a larger number of photons when there's going to be a long duration, a medium number of photons when there's going to be a medium duration, and a short number of photons, I mean a smaller number of photons when there's going to be a brief duration. So this thinking actually doesn't hold water and isn't correct, but it's the way that it's very useful to explain why I was motivated to do the experiment. Then I'll show you what I got. Okay, whoops. Okay, so what I did was record the data in terms of photon counts. So I turned on a low-level light source, recorded photon counts. At some point after the first minute, a random source, which was a quantum random source, crossed with a pseudo-random source, so therefore a truly random source, was used to determine the future duration of the light source. How long was this experiment going to be run in the future? And then we looked at what happened in one and see if it correlated with the duration. So that's simple experiment. This is the setup, which is just to let you know that it's a very much a student setup. Like we have things like a voltage crank that actually has a rubber ratcheting thing to ratchet up the voltage because we didn't want to interfere with it. We were not sure about interfering with the voltage inside of the electronics because they're a student setup. It costs $7,000, which isn't a lot. What else do we have here that's kind of wonky? Oh, we have an Arduino board that's controlling the whole experiment. There's nothing about this that's very sophisticated. This is like, I literally did it in my closet. This is my closet. This is where I did it. It's just a tube with a light source at one end and a photomultiplier at the other end and a photon counter here and a voltage isolator here. So simple, oh, and the computer recording the data here. Simple and almost absurdly simple. But the results are kind of fascinating. So this is in a pilot experiment using the double slit. The Poisson rate is basically equivalent to the number of observations of photons within a 10-second, really 11-second counting period. And you can see that the total on-time duration, which means the total duration of the experiment, the light source, is increasing here. Okay, this is number of seconds. Or I'm sorry, yeah, there's number of seconds. When you have a very short duration where after the choice, it's chosen to turn right off, this is where we're at before the choice. This is where we're at, the mean before the choice, when it chooses to go on a little longer. Here's the mean when it's going to go on a little longer, and the mean when it's going on a little longer. You'll also notice that after the choice, the mean is increasing in parallel with these values, right? Again, I think that has to do with electron stimulation of photon emissions from electrons in the photomultiplier, but I'm not sure. So the point here is that it does match the prediction that the future duration of this experiment is actually leaking back in time somehow with these photons that are kind of telling on the future. I redid the experiment with a single slit. I had a very brief meeting with Roger Penrose when I told him about this, and he said, try a single slit because it's going to make the interpretation easier. And I thought that was a good idea. Also, he's really smart. So here we have a single slit. We've got, again, 4 different durations here. This is the time of the decision, so the time of the choice. And you could see that the mean photomultiplier output before the choice is in line with the mean photomultiplier output after the choice. And that seems to be dependent on the duration. So that's experiment 1. Here it is baselined and with error bars, so less impressive, but it's important to baseline all these because of the variety of changes that in temperature and stuff throughout the day. This is experiment 2, baselined in with error bars. This is experiment 3, baselined in with error bars. This is them all combined, baselined in with error bars. Again, you see how these values are definitely above, even before the time at which the decision of the duration is going to occur is clearly in the future. I mean, I think that should be really clear. There's no weak measurement here. This is a count of the number of photons. This is as collapsed of a wave function as you could get if you think about those things. So basically, the upshot is that via multiple statistical methods, the sigma ranges between 5 and 6.6, and then it was replicated independently by Winthrop-Williams at UC Berkeley with a sigma of 5.5, though he did daytime and nighttime recordings, and I've subsequently found that daytime and nighttime actually differ quite a lot, in fact, seem somewhat opposed. There's implications of that, but in any case, if you'd like to read this paper, you can find it here at that URL. So basically, I've been doing this experiment for at least 2 years since I gathered the data I just showed you, and it keeps happening. So I keep finding the same effect. It does not go away. In fact, it's so reliable that now I would be shocked if I didn't see it. So at least I am one person in the universe who am convinced that on the seconds to minutes time scale, photons can tell on their future state, not even their own future state, the future state of their friends who are also in the same experiment, or essentially the future state of the system. What's the explanation? There's a bunch of different theoretical explanations from how this kind of retrocausality could occur. I don't have the physics chops or the mathematics chops to go through them and figure out which one of them matches this observation. Hoping someone out in the universe can trust me and trust this other replication that this happened. But I'm not spending a lot of time messing with theory. I'm more interested in the practical implications. The theory that I'm thinking about a lot here is gravitational collapse, just because photons they do have a certain mass equivalence because they're energy. And so thinking about how that could work in terms of gravitational collapse is really interesting. I'm not sure it tells the story, but I just wanted to put it out there that I think that's really interesting. Okay, so what in relationship to UAPs, right? I mean, this all feels like pretty, I don't know, ethereal, or like, oh, interesting effect. What does this have to do? Maybe nothing, maybe something. I'm super interested in the relationships of different countries and forms of time travel concepts that they will admit. So now we're switching to the part of the talk where I'm talking about what are the possible relationships to UAPs, and what speculations can we, if we assume that there's this kind of informational time travel, so information from the future leaking back in time, that is a physical process that is essentially fundamental to photons, at least, then what does this have to do with the price of tea in China, or the fact that China banned time travel? Well, I think it's interesting that China bans time travel, but at the same time, there's this new movie out called Everything Everywhere All at Once, which is like people in Taiwan are raving about, and the Chinese apparently love it, even though it's not being shown in China, but there's like, it's not being banned either. And this movie is all about the version of time travel where you have multiple timelines in multiple universes. It's all about that version of time travel. And so they consider it not a movie about time travel, and yet it is all about these multiple universes. So what does that tell us? I mean, to me, it just seems to me like there's a desire for people to think this way. So this is from Minute Physics on YouTube. This is a plot of all these different movies and how they relate to different timelines, right? Looping back and forth or erasing timelines and things like that. There seems to be a lot of willingness for people to think about time travel this way. And in fact, that's the first conversation I have with people when I talk about time travel, is they're thinking about these multiple different choices branching off and these universes looping back. And it feels to me like that's probably the wrong path. And I guess it's just based on intuition, but I sort of get these clues, like this weird desire for China to support something that shows multiverse travel, but not something that would be more like retrocausality. So that's interesting. That's not proof. I'm just saying culturally interesting. What do I think is going on? I think that, wild speculation alert, I think that it's more like this. I think that we have retrocausality to the past, forward causality to the future. Those things are happening. In the present moment, though, interestingly, I think we have something that may influence the energy to matter transition in the present moment. That's like a time loop. And photons may be particularly adept at this. In fact, this may be something that is relating information production to energy matter transition. And that is a total intuition. So I'll just leave that there. But I do have this sort of sense of, and this is the way I've always worked intuitively, and I've had pretty good track record with working that way. So I'm just going to have to just deal with it for the next few minutes because I'll get through it soon. But I have this feeling that photons do time differently, so that they're solving the universe all at once. And it's not just a feeling, actually. This is science-based. Here's an example. So there's this principle of least time. So Feynman talks about it with the example of a lifeguard. I think, and this is a illustration by Atish Bhatia. So you have a lifeguard on a beach and you have a drowning person, and here you have the shoreline. So what's this lifeguard's best plan? So you might think, go in a straight line. That's going to be the fastest way to reach that person. Well, that's not true, because actually it takes longer to swim in the water than it does in the air. So that's not a good idea. Oh, well, if that's the case, minimize the amount of time you spend in the water and spend most of your time on the beach. Well, actually, that's too far out of your way. That's going to take too much longer, because even though you're spending less time in the water, you're spending more time overall. So the path of least time, or the principle of least time, is this C path. You sort of choose where to enter the water, where it's the perfect distance to the person drowning. And in fact, lifeguards do this all the time, and dogs, in fact, do this. It's not that they're doing calculus in their heads. It's that we've evolved to be able to figure out that this is the way we should do things. But photons are doing it too. And here we go. So we have some 3 different wavelengths hitting a prism. And we've all seen light bend when it hits a glass, or this might be water, actually. I don't know. Anyway, whoops. And so you see the light bends, and it knows exactly the angle to bend to follow the principle of least time. So when I say it knows, I don't really mean the photons are like thinking, or that they're psychic, or that they're conscious. What I mean is that's what it seems like. It seems like they're acting like a lifeguard. And by that, I mean, it feels like they, so the way, I'm gonna have to stop this and share this other thing to give an example. All right, so our experience of time is like, here's a graphic of our experience of time. Generally, when people talk about it, we still think of it like this. So here's our experience of time. The blue bar is all right, I'm going to scroll down. The blue bar is our experience of external reality. So first we see the landing on the moon. This is not to scale. Then we see 9/11, coronavirus, and eventually we get to the beautiful future that was promised us with the whole Jetsons flying cars and the tower in the sky. Okay, so that's the way we tend to sort of see these things. Notice that when you're here, that future does not exist yet, right? We think about time like that. That's not the way time works in the physical world, but that's how we perceive it. And so that's why we get pretty confused about these ideas related to time working in different ways. But the idea of the sort of Lagrangian or integral path or lifeguard approach, hold on, let's see if we can get here. Now our attention or our experience is yellow. Is that all that stuff is solved all at once? It's just our conscious experience that is taking its time in a linear sense and going over all the pieces of it. So it's like one equation to rule them all. And that equation is some kind of a Lagrangian equation. So that's the idea. Let's go back to this. But I did have to share my screen for that. So anyway, this idea is enter full screen. So this idea is consistent with this pretty neat paper published in 2018, where they some folks worked on this transoceanic autonomous underwater vehicle, and they wanted to make it the path planning as smooth as possible, so it could be as fast and as uneventful as possible, and it seemed to work. So in other words, they used a simulation of the next 8 to 10 days to calculate what this path would be, and it worked really well. Now, what I'm talking about is the idea that instead of a simulation of the next 8 to 10 days, what if you could get information from the actual next 8 to 10 days that could help you bring into your conscious experience sort of what is already known in the universal sense from a God's eye point of view about the way space-time is evolving. So that's the idea. So I'm going to stop here, and well, I have a few more slides, but basically questions that I think we ought to ask ourselves, and these, you all may be asking yourselves these questions all the time or not. I think they're really important. Is informational time travel, the kind that I'm talking about, where photons can reveal future space-time events, is it enough to produce UAPs? I mean, literally, could you produce an actual piece of information perceived by both radar and human senses by using photons and their interactions with electrons and being able to manipulate that? I mean, I don't know, maybe. Why do these signature management events occur? So why are these things disappearing? Why are these things not making heat trails? We call them signature management. Maybe that there's no signature, right? But anyway, what is the message there, if there is a message? Could we imagine more controlled usage of E equals mc squared? So the idea that we could potentially control in a really subtle and communicative way the relationship between matter and energy, photons and electrons, and cause some of these events. That's related to question one. I've always been wondering, why be visible? These UAPs, why be visible? Obviously, there's some kind of communication there. If so, what's the message in the movement and the shapes? Can we put ourselves in the position of potential UAP, UFO creators of different sorts, whether foreign adversaries or ourselves in the future or aliens or what, you know, whatever people think, like, and ask what information would we want to convey if that were the case? To me, the key here is that in all the science fiction movies, it's all about humans traveling, as if humans need to travel to shift some kind of story or information. But information itself is all that's needed. If we could send back to ourselves at the beginning of coronavirus a lot of the information about what would unfold, it would unfold differently. Does that mean there's a different timeline? No, it means that the Lagrangian calculation told us to do that. So it's, anyway, it's very interesting. Okay, so this is the nonprofit that I created called the Institute for Love and Time, or TILT. It's focused on time travel, mental informational time travel, and also trying to understand the science of experience of unconditional love, which I think is super important for our planet and our people. Also, this conference that I created, I've been working on for a couple of years, and now I'm working with Daniel Sheehan at University of San Diego. We're having an invitation-only conference in July. We have about 40 physicists and philosophers of physics coming to talk about how to create a time machine using quantum information. So that's exciting and a branch off of this work, and it's sponsored by TILT, the nonprofit. And just a few inspirational quotes. Another line from Kevin Knuth's article: we're constrained by the belief that some things cannot be for the sole reason that we lack the ability to imagine them. Barbara McClintock, who's one of my favorite Nobel laureates, if you know you are on the right track, if you have the inner knowledge, then nobody can turn you off no matter what they do or what they say. And Mary Curie, another Nobel laureate: nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less. And I just want to say thanks to you APEC folks for taking a chance on me, especially Tim Ventura. I hope I didn't disappoint. The Bial Foundation, the scientific committee at Bial, some bursaries from Bial, the Jim and Christina Grody Hummingbird Foundation, the Robert Wood Johnson Foundation, Experiment.com, Winthrop Williams, Teresa Chung, Northwestern Research Team, the IONS Research Team, the Windbridge Institute, Hibsco Limited, and all the donors to TILT. Thank you all very much.
Wonderful. Well, Julia, let me do this. Before we do anything else, as is customary, I want to give you a giant applause. Everyone, please give Dr. Julia Mossbridge a giant applause. Julie, that was a wonderful presentation. That was awesome. Thank you so much for joining us.
Oh, now, I'm so glad. You know, when you're sort of doing these things into the void, you never know if people are even like,
oh no, that was
helpful.
That was completely wonderful. So we normally do kind of a Q&A session, and that I mean we have an hour staked out for that, and you're kind of running ahead of schedule. So, we're used to kind of being mellow and working around things. Are you able to stay with us for Q&A?
Yes, I'm happy to stay with you for Q&A. I can go for another like 45 minutes if that
Yeah,
works.
yeah, that'll work great. Okay.
Okay.
Well, so let's do that then.